Welcome to week 2. This week we will discuss the relational database um, management systems and structured query language. So we will discuss the concepts of relational database management systems and relational models. We will then get an overview of standard query language, which is going to be the first one in the two-session series. We will also cover the introduction to NoSQL databases and talk a little bit about additional toolkit that data scientists, as statistical coders, data scientists utilize as well. Specifically, we're going to be talking about the Linux and the versioning control and the GitHub. So the relational database management system is a database management system based on the relational model, which was first described in 1969 by Edgar F. Codd from IBM. Relational model is a model where all data is represented in terms of tuples, which is a finite ordered list of elements grouped into relations. The purpose of the relational model is to provide a declarative method for specifying data in queries. So discussing the concept of RDBMS, we should also discuss the database normalization. Database normalization is a process of restructuring a relational database in accordance with a series of so-called normal forms in order to reduce data redundancy and improve data integrity. Normalization entails organizing the columns and tables of a database to ensure that their dependents are properly enforced by database integrity constraints. Normalization is accomplished by applying some formal rules, either by a process of synthesis or decomposition. So normalization is about breaking the data sets into separate informational units to avoid redundancy. So let's say you have a data set about dogs and their owners. So it lists an owner, Joe Smith, that owns a dog called Bubble and the other dog called Pirate. So in this kind of data set, you have two informational units. One is about the owners, their name, their addresses, their contact numbers, etc., and the other one is about the dogs, listing their, the pet's name, age, maybe medals, and some other information. So in this data set, you would have two informational units, and the redundancy will come from listing. So let's say John Smith owns two dogs, a pirate and a bubble. So John Smith, if you would put it into Excel model, you would have to have two rows listing John Smith twice for each pet. In relational database, you would split those two into two separate tables, and identifying each unique record in both tables as using some sort of primary key, which you will then, using those keys, you will then connect those tables to connect the fact that John actually owns two dogs. All right. So let's look at the other example. So example on the left demonstrates the concept of the key. So in this case, we have a table with maybe some users that their login names, first and last names. The second one, the second table only has two columns. One is the phone, the other one is the login. So login in this case is the login name for each user in the first table. So in this case, Samuel Clemens had created a login mark, and that's how he's uniquely identified in that table. So we know that Lion Kimbrough or Amber Straub could not have created another login named Mark. So it's unique, and it's a primary key that identifies Samuel Clemens in that table. In the second table, where we decided to store phones separately. I'm not quite sure why we'd want to do that, but again, this is a demonstration. And the reason I'm not sure is because phones are unique by themselves. So in other words, two people cannot have the same phone. But in any case, so the phones are stored separately, and to tie that phone to Samuel Clemens, we would use Mark primary key from the first table and indicate that as a foreign key in the second table. So if we would want to pull all list of all first last names and their phone numbers, that we would use these two tables, and that's how we would link these two records. On the right side is basically the concept of the relational model. So we see that there's some sort of probably a construction company database that lists in the top table, it lists the activity code and activity name. And activity code refers to the number, and then the name for that number is actually activity that you do on interstate highways. You can either patch them, overlay them, crack seal, etc., etc. In the second table at the bottom, you see the date. It's you have your transactional data. So you have the date, you have the activity code, and the route that that activity was performed on. So in this case, we're not listing activity name in the bottom table. We only list the code 24 because then we can link that. That would serve as a foreign key when we link that together. In case we would want to see all activity, or for example, if we would want to see all activities, overlay activities 24 coded 24, we could also do that using both tables. Actually, on the right table, it doesn't show that we use an activity name, so we could as well use just one. But if we would want to add additional column that would say activity name after activity code, we could do that. So let's talk a little bit about the structured query language. So most relational database management systems use structured query language, or SQL, data definition and query language. SQL was initially developed by Donald Chamberlain and Raymond Boyce at IBM after learning about the relational model from Ted Codd, also from IBM in the early 70s. In the late 70s, the attempt to commercialize software was attempted by Relational Software Inc., which is now Oracle Corporation, headed by Larry Ellison. That saw the potential of the concept described by Codd, Chamberlain, and Boyce, and developed their own SQL-based relational database management system with aspirations of selling it to the U.S. Navy, CIA, and other U.S. government agencies. And if I'm not mistaken, they renamed it to Oracle because that was the project name when they started it for CIA. In SQL, tables and query results are a list of rows. The same row may occur multiple times, and the order of rows can be employed in queries. The SQL language is subdivided into several language elements, including clauses, which are constituent components of statements and queries. In some cases, they are optional. Expressions, which can produce either scalar values or tables consisting of columns and rows of data. Predicates, which specify conditions that can be evaluated to SQL 3-valued logic, true, false, or unknown, or Boolean truth values, and are used to limit the effects of statements and queries or to change program flow. Queries, which retrieve the data based on specific criteria, and queries are an important element of SQL language. statements which may have a persistent effect on schema and data, or may control transaction program flow, connection sessions, or diagnostics. SQL statements are always end with the semicolon statement terminator. Though not required on every platform, it's defined as a standard part of the SQL grammar. So let's look at the basic SQL statement. So you always start with the word select. Then you list the columns or column that you want to, which values would you like to select. Then you put statement from, and listing the table or the tables from which in which those columns are located. Then you put in the statement where, and listing the condition or conditions that you want to specify. So, for example, you want to select movie titles from, you want to select from a database about movies. You want to select movie title, which is one column, and then movie year from the movie table. Okay, where the movie year equals 2000. So this will basically select all movie titles, and it will also indicate their year from that table where the movie for the movies that were created in the year 2000. So let's talk about the aggregate functions in SQL that actually are very helpful, especially when you're trying to work with the data statistics. So the functions are basically performing some calculations, descriptive calculations on the columns, and they are min, max, sum, average, count, and count star. So minimum and maximum return, accordingly they return the minimum value in a given column or the maximum value. Sum will return the sum of numeric values in a given column. Average will return the mean value of the given column. Count will return the total number of values in a given column, and count star returns the number of rows in a table. Okay. So a couple of examples. For example, we have a table that lists employees, their names, their titles, their salary, and we want to find out what is the average salary in our company. So the statement that would help us do that is select average, which is the aggregate function. Salary is the name of the column. From employee is the table name where the salary information is located. Where title is another column in the employee table, equals programmer. So this statement will return an average salary for just for the programmer positions in the company. If we would want to know the numbers or the number of all employees in the company, we can use the second statement, select count star from employee. Recall that count star returns the number of rows in a table. So it will count the table, assuming that all records are unique. It will count the rows in the employee table, and will return that number. So how do we insert? So as we mentioned, all data is located in tables that are connected via the different constraints and keys and constraints. So how do we insert new rows, new data into those tables? So first of all, we need to understand the what columns are there in the table. So in this case, we have an actor table that has actor ID, actor's first name, actor's last name, and actor's gender. And let's say we want to insert a new actor, James Stewart. We would use insert into, statement, then we would use the table name, which is actor. Then we would use the keyword values, and in parentheses we will include the each value for each column accordingly. So 101 is the name for actor ID. James and Stuart are first name and last name accordingly, and M is the gender of the actor. So you notice that the first one, actor ID, is not included in quotes, while all other information is. So you may wonder why. This has to do with the types of data types of each column. So the first column is numeric. It only stores numbers. The second column type is a string, or in SQL it's also called varchar. Varchar is in varchar you can store anything you want, either not anything you want, but you can store either numbers or alphanumeric symbols. However, it will be read as a string. So in other words, you're not going to be able to perform calculations. Let's say if you put 101 in quotes and store it in the actor's first name, and then you will try to add actor ID to actor's first name, it's going to generate an error. So once you've done that, the statement that will actually save it is called commit, and basically that's how you save the record in the database. Update is another keyword that will let us perform manipulations on the data. So let's say we want to search for missing data in the database and change their values to something that we would need to use in our analysis. So for example, by the way, the missing values in relational database, specifically in MySQL, are indicated as nulls. So what we need to do, in other words, is to find all null values in the column actor. I'm sorry, in the column actor's actel name, actor's last name, in the table actor. So we would use the statement update, keyword update. There are a couple of options that you can also add, but we'll ignore them for now. So you will use the update table name, then the keyword set, and then you would indicate your condition. What exactly do you want to update? So in this case, we're updating the actor's last name to unknown. Let's say that's what we want to have on the report. If actor has no name, we don't want it to be just an empty space. We want it to say unknown. Where, keyword where, actor's last name equals null. So we specify the condition to change all values, null values in that column, actor's last name, to unknown. Now the third statement that we use to manipulate the data inside the tables is delete. So how do we delete the record? Delete, keyword delete from, then the name of the table, and in this case it's called some log, keyword where, and then the name of the column, user, equals J. Cole. So we want to find in table some log user or users who have username J. Cole, and we delete everything by default. Then the second part of the statement, I'm going to read it through, but don't worry about it right now. We're actually going to go into the order by. So the second part says order by timestamp column limit 1. So order by will essentially it's a grouping statement, and it will group the data by the timestamp column. Limit 1 limits the number of rows that are returned once your operation is performed. So in this case, it's going to return just the first row. But like I said, don't worry about the second part. So this is essentially just to understand how you delete the records from the table. So some of the statements that will help us further organize the output of our SQL queries that we run on our data are group by, order by, and having. So the group by clause will gather all of the rows together that contain data in specified column or columns, and will allow aggregate functions that we discussed earlier to be performed on one or more columns. So, recall from the previous slide that aggregate functions will let you find information like the average of the numeric data in the column, or minimum, maximum, etc., etc. So as an example, let's say we have an employee table where we have information about employees, including their salaries and the department name, or department number probably in this case. So let's say we want to understand what is a maximum salary in each department. So the statement that would let us achieve that would be select. Then we would use the aggregate function max on the column salary, which will select the top salary. Then we would list the department, and then we would use the keyword from, and then the name of the table, employee. Finally, we will group the results by the department. Understand that maximum salary will return just one number, and obviously you'll have multiple department records for each employee that works in that department. So in this case, we only have one number, so it will show group by department will show that number next to each unique department number. So the order by statement that we looked at earlier is an optional clause which will allow you to display the results of your query in a sorted order, either ascending or descending order. And the results are going to be based on the columns that you specify to order by. So let's say we have a movie database, rather a table with columns that list movie ID, movie title, movie year, and we want to write a SQL query to find the list of all of those movies along with the year, which include the words Boogie Nights. So in this case, we will write a query that will select movie ID, movie title, movie year from movie table, and then we'll specify the condition that the movie title should include the word Boogie Nights. Finally, we will order, and I'm going to talk about the format of this pattern here in a moment. Finally, we will order that by movie year in ascending order. All right. So now let's look in the quotes. So we listed two words, Boogie Nights, and they have a lot of percentages between them. So percentages are actually wildcards that will let us specify a pattern, a text pattern, where we need to select everything, the word Boogie Nights, regardless of whether there's anything before, between, or after them. So this statement will select Boogie Nights if it goes in the beginning of the sentence, at the end of the sentence, or in the middle of the sentence. Now, if we will, for example, remove the percentage sign from the left side of the Boogie Nights, it will only select the statements that it will only select the results where Boogie Nights appears at the beginning of the string. Let's talk about the having clause. So having clause allows you to specify conditions on the rows for each group. In other words, which rows should be selected will be based on the conditions that you specify. The having clause should follow the group by clause if we're using it. Let's say we have, again, let's go back to the employees table that we have that lists the employees along with the department that they're working at, the salary that they're making, and calculate and display the average of the salary in each department if their salary is over 20,000. Right. So in this case, we would use the again we would select the department depth column followed by the average salary in that department. And again, remember that we're using the aggregating function here, average, from employee table, grouping by department. So group by will ensure that the number for each department, average salary number for each department, will be listed next to the department number. And finally, we will use the statement having, and then again, that average salary that we're selecting, we only want to see those that are over 20,000. The in and between statements clauses will help you specify, narrow down your conditions. So let's say you have, again, you have a employee info table where you have employee IDs, last name, salary, etc., and you need to select them from that table, but you only need to select it for specific last names. So you have certain employees, maybe they're over performance, and you want to know what is their salary. So select employee ID, last name, salary. We'll select those pieces of information from employee info table, where, and now you're specifying the condition, last name in, and then you parenthetically include strings with the values, last name values for those employees: Hernandez, Jones, Roberts, and Ruiz. So this will return employee ID, last name, and the salary just in the in the rows where the last name fits into one of these last names. If you use between, you can also specify that by the age. In this case, the last clause will be, the condition will be where age, column age, is between 30 and 40. So let's talk a little bit about NoSQL. We spoke about the relational model in SQL language. Let's talk about the NoSQL databases that you probably heard about a lot lately. So NoSQL refers to as not only SQL, and basically it provides a mechanism for storage and retrieval of data that is modeled in means other than the tabular relations that we encountered in relational models. So the concept for NoSQL actually has been existing since 1960s, but it became more popular in the early 2000s, following the needs of growing corporate data sets. Early 2000, dot-coms just crashed, but e-commerce started popping up, and the average corporate database was like, let's say, eBay or Walmart or Amazon, actually exceeded the limits which traditional technology could handle. So hence was the concept of NoSQL was brought back to accommodate those kind of volumes. So NoSQL database fall into a few types. So key value store, document store, graph databases, object databases, tabular, tuple store, triple squad store database, hosted, multi-value, and multi-model databases. We're gonna look at just three of them, but again, this is a topic on its own. It's actually one of the most important topics in the data science in the coming up years. So I strongly recommend you look into at least one or two. And that has to do with the fact that a lot of data that's going to be coming up in the coming years and used by data scientists is going to be unstructured, so-called big data. So let's look at the first three types. So the key value stores use the associative array, also known as map or dictionary, as their fundamental data model. In this model, data is represented as a collection of key value pairs, such as that each possible key appears at most once in the collection. So in other words, it has, let's say, the key state, and then the value for the state would be each of the 50 abbreviations of each of the state. The NoSQL document store database is quite popular actually, and it's the central concept of a document store is the notion of a document. So in traditional databases, you have your schema, which defines what kind of data you can include into a table, and if you don't provide that data, it's listing it as missing. While each document-oriented database implementation differs on the details of this definition, in general, they all assume that documents encapsulate and encode the data in some standard formats or encoding. And that includes XML, YAML, or JSON, or the binary form Bison. Documents are addressed in the database via a unique key that represents that document. One of the other defining characters of a document-oriented database is that in addition to the key lookup performed by key value store, the database also offers an API which is application programming interface or a query language that retrieves document based on their contents. So in other words, it doesn't matter what structure you have in your document. It's a schemaless database, so whatever you have, it will store. Different implementations offer different ways of organizing and grouping documents. Collections, tags, non-visible metadata, directory hierarchies. So if we try to compare this type of NoSQL database to relational database, concept of collections in NoSQL database will be considered an analogous to tables, and the documents would be considered an analogous of records in the relational databases. But even, it's a rough comparison because they're actually different. Every record in a table has the same sequence of fields, while documents in a collections, as I mentioned, may have fields that are completely different. So let's look at the third type of NoSQL database, graph. This kind of database is designed for data whose relations are well represented as a graph consisting of elements interconnected with a finite number of relations between them. The type of data could be social relations, public transportation links, roadmaps, network topologies, etc. So the advantages of graph database is that it allows, once you design it the correct way, so basically creating nodes and connecting those nodes, it allows you to discover relationships between different nodes, which could be maybe users or cities, etc., etc. Relationships that you would otherwise would not be able to discover with your with a naked eye. So that's the advantage, and it's Neo4j is the most popular open source database, graph database, and the example we see on the slide is actually has been generated by Neo4j, and it's this type of functionality is extensively used in fraud detection. In the government agencies, because it basically allows the database will discover the connections between nodes that you otherwise wouldn't be able to see. Okay, so now that we talked about SQL, let's talk about some additional tools that you, as as data scientists, as statistical coders, will have that are not directly related to data science, but rather to coding. But nevertheless, you as statistical coders need to know. So let's look at the data science environment in general. You have two data scientists that work in a team that located maybe in different departments, in different buildings, different cities. John creates data cleanup code and uses Linux to push it to the shared repository. So repository is called GitHub, and we're going to talk about it in a second. Jane pulls the code and data from repository, models on a clean data, and pushes her code back to the repository. So, in today's interconnected world, data science actually consists from teams. So let's say you have John, whose specialty is to clean up the data, which is actually a huge task that can take up to, like we saw in the previous session, can take up to anywhere between 60 and 90% of the entire project's time. Jane, on the other hand, is great in modeling. So data cleanup falls in more into data engineering, modeling more into statistics and machine learning. So they have their specialties. So John takes the first step by applying methodologies, data engineering methodologies to clean the data up. Once he's done, he's pushing the original dirty data set and the code that cleans that data to bring it up to a tidy format that Jane can model on to GitHub. GitHub is the online repository that lets you control versioning of the software. That's the general purpose. However, lately it's been used extensively for collaboration on development projects. So once the code is pushed to online repository, he notifies Jane by email maybe that the code is ready. Jane downloads the dirty data set, the original unclean data set, along with the code that cleans it up, runs it on her computer, and gets the data in tidy format, which she then can apply modeling techniques. She then pushes that work back to the cloud, to the GitHub. So in the previous slide, we noticed that John and Jane were using Linux to push their code and pull their code to and from GitHub. So they were using Bash, which is essentially a Unix shell and command language written by Brian Fox from the open source project. Bash is a command processor that typically runs in a text window. It can read commands from a file called a script, first released in 1989 and distributed as a default login shell for Linux and Apple's Mac OS. If I'm not mistaken, it's also available in the last window release. So if you have a window, you can probably find it. I'm not a Windows user, but if you have Windows operating system, you probably have it as well. So like I mentioned on the previous slide, Mac OS users can use the Bash shell using the terminal application that comes standard with Mac operating system, and this is the icon. Windows 10 has Bash shell pre-built. But if you're using something earlier than Windows 10, you can install Mobile Xterm as your interface. So some of the commands that you can do once you launched your terminal or Mobile Xterm are essentially related as to any operating system. So you want to move around your file structure, you want to manipulate your files and folders, and that's pretty much what those commands, the commands listed on the slideshow. So to identify, remember it's a command line. So once you start your terminal window, you need to understand which directory are you currently in, and to do that you can use pwd. It will show the path to your directory you're currently in. To change between directories, you can use cd space and then the name of the folder that you want to change to. Or if you want to go one folder up, you can use cd space 2 dots. That will go one folder up. If you want to go all the way to the root directory, you can use cd space tilde sign, which is a weird curvy shape, curvy dash. Folder and file manipulation. So you can use cp to copy files. So in this case, you would need to be in the directory where the file you want to copy is located. Or you can be in the other directory, but then you need to specify the path from your location to that file's location. So you can use cp, then the name of the file, space name of the file, and then the location where you want that file to be copied to. Okay, mv will move or rename file. If you're moving it, you need to specify the new location. If you're renaming it, you need to specify the new name for that file. rm will delete the file. Now, if you have directories that contain files, you will also need to specify an option -r, if I'm not mistaken, to delete that. Otherwise, it will not delete the directories that already have something in them. ls will list the files that are located in the directory you're currently in. mkdir will create a directory. So the command would be mkdir space then the folder name, and then that folder is created in that location where you were when you were typing that command. ls-l will check permissions on the directory or a file, and chmod change the permissions of the file. So there are 3 types of permissions that you can have on any file: are read, write, or execute. And those are expressed as a 3-digit number in the chmod. So chmod 600 data.txt, for example, will mean that the owner may read and write the file. The chan will change the user and group ownership of the file. So again, Linux and Bash shells is something that you need to cover. Unfortunately, it's outside of the scope of this class, but I wanted to bring it up so you would be aware. You can use the external tutorials to pick up on the Linux command if you haven't already. This link is one of the examples, but if you Google it, there's plenty of tutorials, actually pretty useful. So I would definitely suggest you to follow up on that. So now let's talk a little bit about revision control, GitHub and revision control. So revision control is the management of changes to documents, computer programs, large websites, and other collections of information. The changes are usually identified by a number or letter code, termed as revision number, revision level, or just revision. Each revision is associated with a timestamp and the person making that change. Revisions can be compared, restored with some type of types of files merged. So in other words, it's the version of the software, transforming that to most observed phenomena in our real world. That would be the software version. Sometimes you can have versions that are named numerically. In some cases, like for example, Windows at one point was named numerically, but then it switched to the years in which it was produced, etc., etc. So a little bit of history about GitHub, Git and GitHub. So the development of Git began in 2005 while working on the Linux kernel. The first stable version was released in December 2005. Um, the goals set were distributed to have a distributed system. Applying updates should not take longer than 3 seconds. Taking concurrent version system as an example of what not to do. Supporting distributed system workflow, and including strong safeguards against corruption, both accidental and malicious. By itself, the word Git represents unpleasant person in British slang, and the main page that describes Git describes it as the stupid content tracker. So again, before you actually start using GitHub, Git and GitHub for collaboration repository, you need to open an account at github.com. You saw the link at the previous slide. Basically, there is an educational version of GitHub that will allow you to have unlimited features where you can use all features for free. In the state where if you're not going to use the academic version, then you can all code that you're going to publish is going to be seen by public, which is fine. And in this case, it's free. However, if you would want to keep your code private, like many organizations do, you'll have to subscribe. Again, I have the link in the content of module 2 that will take you to the academia version for GitHub. So if you would like to utilize that, you are more than welcome to. Once you have your GitHub account, you can open repositories. Repository is going to essentially be the place where you're going to be storing that's going to store and track versions of your code. To set up GitHub on your computer, again, you do that through the terminal window. There is a way to use the graphical user interface. You'll have to download it from the GitHub, but it's always useful to know how to use Linux and the command line to set those up. So the first thing you need to do, you need to set up your environment once you open your terminal window, and the command on the slide will help you set up your environment. So git config, 2 dashes, they look like one, but they are actually 2. Global, then user.name, and in quotes you can indicate your name on that you used to log into GitHub, to your account in GitHub. The same thing you can do for your username, and you need to indicate the email with which you're logging into GitHub. Then the next thing you can do is set up the origin. Set up the origin, meaning that you're letting your environment on your computer, your Git environment, know what's the web address for the repository that you just opened at GitHub. So it would know where to push the code and where to pull the code from. So once you're done, the next thing you need to do is to initialize your repository on your computer. So let's say you have an empty repository on your GitHub online, and you have a folder with your code. So in order to push that code to GitHub, you need to initialize your folder on your computer with your code as Git. So this is basically, you will change into that folder, and once using terminal window, you would change into that folder, and then you would initialize using git space init command. Okay. So once you've done that, you would use the git remote add origin, and then the link for your repository. You can just copy it from the web browser's address space and paste it here. You don't necessarily have to list .git at the end. It helps, but you can just copy the address. And that way it will be stored in your Git environment on your computer, so that next time you give a command to push or pull, it will know where to do that, the location of your repository. So your next step would be adding all files um, in your working directory on your computer into the cache, and you would do that as using commands git space add space dot. This will add every single file in your directory that you just initialized. Your next step would be committing that, and you would need to use git space commit. The other two options that are not on the screen right now are include the git commit dash m space, and then you would open the parenthesis and list some sort of documenting statement, like for example first update, or something that will let you identify this change that you made to your GitHub later on. Then you would use git push origin master, and this will actually push your code to your Git repository, assuming there were no errors. So again, this is a very, very brief, basic introduction to GitHub and versioning control. But like I mentioned before, as a coders, you would need to be familiar with that tool in order to be more efficient, collaborating in the teams, etc., etc. So this slide has some links that you can use, external links from GitHub actually, that you can use to get more information and learn on your own how to use. And again, just like with the Linux and Bash shell, I would definitely recommend you to learn that early on.